all it's like you kind of go through a bunch of your changes, like old shit shot up, sitting at the.
These are out of your book. There's a section called optimization, and it's the end of chapter 3. It might be section 3.8. Again, we've been using the same book forever, and the sections switch. But I think it's section 3.8. The section's called optimization. So if you find. You're back?
Yeah. I just took some Alka-Seltzer
Okay.
and a break because I was here all day too.
Okay. All right, so during the summer months, Terry makes and sells necklaces on the beach. Last summer, he sold the necklaces for $10 each, and he averaged 20 per day. When he increased the price by $1, he found that his sales decreased by 2 per day. Find the demand function. What they mean by the demand function is and they tell you to assume that it's linear. Generally in textbooks it's going to be linear. In real life it might not be. But it's a function in which one of your variables is your price and your other variable is your demand. And it does not matter which one you put it in. I mean, some economics books, if you run into an economics book, they're going to tend to like make one choice and then stick with that through the whole book. But in terms of mathematics, and so you're in Calc 1, and in terms of mathematics, all you care about is the relationship. You don't really care which one is which, all right? So I just wrote down price for X and demand for Y. I'm just going to leave it like that. So a couple of points we know are on this line are $10 and a demand of 20 and $11 and a demand of, when I increased my price, 18, exactly. So when I increased my price by $1,
You went down by 2.
I went down by 2. So slope is y1 minus y2 over x1 minus x2. So basically difference in 2 y's, difference in 2 x's. The way I have it set up, I'm getting -2 for my slope, which it should be negative because you were going down in demand when you increased your price. So when y is 20, x is 10, and so b equals 40. So y equals -2x plus 40 is my demand function, where x is my price and y is my demand. So that was part A of the question. If the material for each necklace costs $6, what should the selling price be to maximize his profit? So to do part B of the problem, I need to make sure that I know that profit is revenue minus cost. And revenue is money you take in. Okay, so he's charging X dollars per necklace, and he's selling -2x plus 40 necklaces. Okay, this is his price. This is how many he's selling. So price times how many he's selling is giving me revenue. And then his cost is $6 times the -2x plus 40. We're assuming he's selling all he's making, like he makes them as people walk up and get them, I guess. There's no discussion here about leftover inventory, so we'll just assume that he sells all that he makes. Okay, so this is the demand, so the cost is $6 times the demand.
Okay.
And again, you could have flip-flopped these.
But it wouldn't have given you
but,
decent equation that.
well, no,
everybody's-
it probably
Well,
would've, and
well-
I really think it probably doesn't matter. I
Most
don't-
people are comfortable with y equals mx plus b anyway.
Yeah, well, no, you would have still had a y equals mx plus b, it's just that you would have interpreted the x
Oh, yeah,
as
okay.
your demand and your y as your price.
Okay,
And you know, whether the numbers would have been messier, I mean, the slope would have been, let's see, it would be y minus 40 divided by 2, so it would be negative a half would have been our slope.
oh, okay.
All right, so anyway, we get negative 2x squared plus 40x plus 12x minus 240. Negative 2x squared plus 40x plus 12 minus 240. All right. So that gives us negative 2x squared plus 52x minus 240. We want to know when that's maximized, and we're in calculus class and not college algebra class, so instead of finding the vertex, which you could do in college algebra class, we are going to find our derivative. And we get minus 4x plus 52, is that a t-ball kind of problem by now? Power rule, okay. And the reason why is because maxes and mins occur either where your first derivative is 0, undefined, or at an endpoint. Okay? Here, our endpoint, we have a low endpoint, we really don't have a high endpoint. Our low endpoint would be a price of $0, but we know that's not how he's going to maximize his profit. Okay? He might minimize his loss if he just gives them away and quits making them, but he's not going to maximize his profit. So I don't have to worry about the endpoints for this particular problem. Sometimes you do.
Wait. Sorry, I'm thinking the second derivative of that.
The second derivative is negative 4, so it's concave down. So we're going to have a max. I'm sorry, is that where your train of thought was going?
Yeah, because it's assuming, because it previously was assuming that it was,
The demand function's linear, not
Oh,
the
I'm
profit
sorry.
function. Yeah, the demand function was linear.
Sorry.
Okay, so solving that for 0. Again, we found our first derivative. Why? Because the original profit function will hit a max where the derivative is 0 or undefined or at an endpoint. I don't have to worry about endpoints for this word problem. I don't have to worry about undefined points of this word problem. Thus, the max is going to occur where the first derivative is 0. Okay, so the solution tells us where max or min occurs. We technically should double check that it's really giving us a max, but we will, all right? So negative 52 has to equal negative 4x, and then negative 52 divided by negative 4 equals x, and 13 if you think about decks of cards. And so that tells me that he should price them at $13. If he prices them at $13, according to my demand function, he is going to sell 14 of them, right? Negative 2 times 13 plus 40 would be negative 26 plus 40. So that is 14. So he's going to sell 14 necklaces at $13 a piece, and his revenue is going to be $13 times $14, but his cost is going to be $6 times $14, and revenue minus cost is profit. So, I don't know, somebody multiply 13 and 14 by, yes, the same. My demand function tells me how many he's going to sell according to price. So we got a price of $13. So I took -2 times 13, which gave me -26, and then -26 plus 40 is where I got the 14. So what's 13 times 14? 169 plus 13 more. Wait, what?
182. Finally using this thing for the first time ever. Since 1983, I guess so.
Get $98 profit. All right, so Terry will earn a maximum profit.
And you know if he's selling them on the beach, he ain't paying no taxes for it either, so that's all profit.
A maximum profit of $98 when he sells the necklaces at $13.
Depends on how many hours he's working a day at this.
Dude, he's living on the beach. Most of the time, he's surfing.
Yeah.
Probably eats fish,
Yes.
catches and spearfish.
Yeah.
Yeah, this is depending,
If he's only
depending
working-
on
if
what
he's doing
state
that
he's
about
living
8
in, we
hours a
won't
day,
quite